What's up guys? I'm Zach with Bus Voyage, and today we are talking about building your DIY electrical system. And more specifically, this is going to be a beginner's guide for the overarching, plan for how to build your electrical system for your bus, van, or really any kind of DIY electrical system. So let's jump into it. You're going to want to do what's called a power audit. You need to look at the items that you're using on a daily basis. You need to figure out how many watt hours they require, and then you need to have batteries equal to or greater than that amount of watt hours. But don't worry, everything's gonna be linked below. So if you have any questions or you wanna reference exactly what I'm talking about or exactly what these equations are, it's all gonna be available below. So go ahead and check there. It's important to know that batteries are sized in kilowatt hours. Now, it's a lot of times you'll see batteries sized in amp hours. However, these are assuming usually that you're working with 12 volt batteries. Sometimes batteries are measured in 24 or even 48 volts. So the amp hour measurement can be a little bit misleading. So for that reason, I prefer to measure in watt hours or kilowatt hours. I could have a 12 volt battery, I could have 24 volt batteries. Either way, 4.9 kilowatt hours is 4.9 kilowatt hours. Once you've sized your battery, the next thing you want to do is size your panels. You need to figure out how many panels do I need in order to charge the battery capacity that I have. So the general rule of thumb for this is assuming 12 volt batteries, however many amp hours you have, you want twice as many watts of solar. This will generally give you an idea of how many solar panels it'll take to charge these batteries in a given day. So you've sized your electrical system, you have a rough idea of the size of everything you want. Now it's time to actually figure out what components do I want. So when figuring out components, I would start with batteries. Batteries are going to be the most expensive part of your system and one of the more technical. So when it comes to batteries, the first thing you need to think about is what kind of battery do I want? There's three main types of batteries that people use. However, in my opinion, there's only one that I would really go for. So you've got your lead acid, you've got your AGMs, and you've got your lithium. Now, lead acid are old and honestly, they're not even worth talking about. You can look them up if you'd like, but you'll find that it's very old technology. Now, the real competitors are AGM and lithium. Now, both quality batteries, AGMs are going to be a lot cheaper, whereas lithium will be a lot more expensive. However, there's a couple major drawbacks to AGM. The first being that you don't want to discharge your batteries below 50% capacity. Now, this is huge because if there is a desired amount of watt hours that you're hoping to get out of your batteries and you want to buy AGM batteries, you're actually going to have to buy double the amount of batteries that you actually want to be able to use in a given day. So when you factor this in, it makes the prices a little bit more similar. Then on top of that, the lifespan of lithium batteries is going to be much higher than AGM. And when you factor this in, lithium, in my opinion, is the obvious choice. Now, up front, it's going to look quite pricey. However, trust me, if you can afford it, I definitely recommend going with lithium. And in a second here, we're going to talk about some budget ways to buy lithium batteries and save a little bit of money. So hopefully you have an idea of what kind of batteries you're leaning towards. So then you're going to want to look at, where do I buy these batteries? Now, if you've done any research, what you'll find is the number one pick is Battleborn. Now, I haven't personally used Battleborn, but from all the research I've done, Battleborn looks like an amazing brand. They have high quality batteries. They have a 10-year warranty, which honestly is probably the biggest selling point in my opinion. However, they can be a little pricey. For 100 amp hours at 12 volts, you're looking at about $950. Now, for my system, which is roughly equivalent to 4 of those, that would cost me about $4 grand in batteries, which is kind of ridiculous. So I started doing some digging, looking for any alternatives. After a little more research, I found BigBattery.com. Now, BigBattery.com would 100% be my recommendation. They have a variety of batteries, which again, I will link below. All of the batteries have been tested and are guaranteed quality, and they are such a good price. So the batteries that I bought ended up being $899 for 2.45 kilowatt hours. Now, if we do the math real quick, these Big Battery brand batteries, not only are they $50 cheaper, but they're actually over double the capacity. They're 2.45 compared to 1.2 kilowatt hours. So really, they're less than half the price of Battleborn. I highly recommend these batteries. And not only that, when we got these batteries in, they went above and beyond my expectations. So they have a screen which will read you the voltage built in. So you can easily check that and know exactly what the voltage of your batteries currently is. And on top of that, they have built-in 130 amp circuit breakers to make sure that they're never discharged at too high of a rate. So I absolutely love this feature, and like I said, once again, I highly recommend it. So hopefully that gives you some insight on batteries. So once you've picked your batteries, the next thing you're gonna want to pick out is your solar panels. So once again, the general rule of thumb is you're going to want twice as many watts in solar as amp hours in 12 volt batteries. The batteries that I bought are actually 24 volt. In order to convert this, we can just multiply the amp hours by 2. For my setup, I would be looking at 800 watts of solar panels. So once you know how many watts in solar panels you're looking for, time to find a place to buy them. So there's a couple different types of solar panels. However, the main two are monocrystalline and polycrystalline. Now, there's not a huge difference here. Polycrystalline will be a little bit cheaper, while monocrystalline will be a little bit more expensive. However, monocrystalline will also give you slightly higher output. In the end, it doesn't really matter which one you pick, but if you can afford it, I would recommend going with the monocrystalline. So when it comes to solar panels, most solar panels tend to be quality. You know, as long as you're not buying, some weird jank ones, any solar panel off Amazon will probably do the job. When it comes to solar panels though, I would recommend buying the cheapest ones you can find that have decent specs and seem to do the job. For me, that was from a company called Santan Solar. Santan Solar is awesome because they resell used solar panels. Now, I wouldn't necessarily buy used components for everything in my setup. However, solar panels is one that I definitely would. Solar panels are honestly rated to survive longer than most of us. For the money that we're gonna save, I definitely recommend Santan Solar. So I bought 370 watt panels from Santan Solar and I actually bought 2 of them. I'm pretty happy with it. And the cool thing about solar panels is you can always upgrade. As long as you have more room on the roof, throw another one up there and increase the rate of charge. Hopefully you figured out your batteries and your solar panels. So the next thing you need to figure out is your charge controller. A charge controller is for regulating the amperage that's coming in from your solar panels to your battery so that your battery can be safely charged. The reason that this needs to be done is because your solar panel will provide varying amperages depending on the sun, the amount of energy it's transferring. In order to rate a charge controller, there are 2 numbers that you're gonna wanna pay attention to. You're gonna find a voltage and an amperage on your charge controller. The voltage is the maximum amount of volts that it can handle coming in from the solar panel. The amperage is going to be the maximum amount of amps that it can output to your batteries. I found a really awesome calculator online, and I'll go ahead and link that calculator below. And so that will help you, as long as you have your batteries and your solar panels figured out, you can throw all the numbers from those into this calculator and they'll give you data on exactly how large of a charge controller you need. This brings up an interesting issue because I've considered expanding and adding more solar panels, and if I do that, I'll actually need a higher rated charge controller for more than 40 amps. So the cool thing about this is if you end up running into this situation, you can actually just buy a second charge controller. You can hook them up in parallel, and between the 2 of them, it'll be able to take care of regulating all of your power down. So don't stress about buying a bigger one because you can always just buy a second if you need. Now, hopefully you have an idea of what a charge controller is and what you need. The next thing that I would look at is an inverter. Now, you don't need an inverter if you don't want AC power. However, you probably want AC power. When looking at an inverter, what you're gonna wanna keep an eye out for is pure sine wave inverters. This comes down to efficiency. I ended up going with the Victron Multi-Plus, and this is great because it's actually an inverter as well as a charger. When I say charger, what I'm talking about is it will charge my batteries using shore power. This was a huge benefit for me because if I'm parked somewhere that has access to an electrical system, say at a friend's house or a family member's house, or maybe an RV hookup somewhere, I can plug into their electrical system and I can actually draw power and charge my batteries directly from there. When it comes to inverters, you're going to want to look at how many watts you need. Personally, I ended up going with a 3,000 watt inverter. This is because, as I mentioned earlier, I have a lot of devices that I want to power, and I wanted to be able to utilize the luxuries of home in my bus, because something else to think about is that a lot of AC appliances will have an initial surge in power as soon as they turn on. For example, if you have a microwave that's rated for 1500 watts, when you initially turn it on, it could actually surge as high as 3000 watts. For the most part, I wouldn't worry about this because inverters are built to handle this. I would check the specific inverter you buy just to make sure this is a feature that is included in yours. But I think with most modern inverters, this is pretty common. Now, when it comes to inverters, you have a kind of a wide variety. Some of them can be as cheap as a couple $100s, and some of them can be as expensive as a couple $1,000s. Adding a charger into your inverter will definitely drive up the price. However, for me, this was something that was important because I wanted to have the ability to plug in and power my batteries off of a friend's house, a family member's house, an RV hookup, or just wherever I was at. Okay, so we've got our batteries, our solar panels, our charge controller, and now our inverter. So the next thing we should talk about is your DC fuse box. This is going to be the connection for your DC appliances, like a max air fan, maybe a water pump, maybe some lights. For these items, it's gonna be extremely important to have a DC fuse box. You wanna figure out roughly how many DC appliances you're gonna have, buy a fuse box that can handle equal to or greater than this number of appliances, and you're probably good to go. I got a 12 fuse DC fuse box, and I'll go ahead and link the one I got in the description below if you're curious. So those are going to be your main components that you need for your electrical system. Now, on top of that, you're going to need fuses, wires, circuit breakers, and also things to hook up your AC and DC system. So let's talk about wires, fuses, and circuit breakers. First of these three that you're going to want to think about are wires. Now, choosing the correct wiring is extremely important. If you choose the wrong wiring, you can run into a couple problems. First of all, you can have voltage drops from the internal resistance of the wires, and even worse, you could potentially have them overheat and start fires. I don't think any of us want to run into this issue. So you're going to want to buy wires that are correctly rated for the amperage that will be traveling across them. There is an awesome chart that you can see right here that will show you what wires you need for what amperages at what distance. The biggest wire you're going to need is going to be going from your inverter to your batteries. And this is because your inverter is going to draw the largest load of any of the components in your system. For my system, I used 1/0 wire. On top of that, I used some 6-gauge wire to hook up some of the other peripheral components in my system. Once you've figured out what size wire you need, you're gonna want to size your fuses and circuit breakers for your system. The first thing that I would recommend doing before you dive too deep into this is look at the inverter that you have chosen and figure out what they recommend. A lot of inverters will actually recommend both wire sizing as well as fuses. So my inverter recommends a 300 amp fuse with 50 millimeter squared wire, which is 1-gauge wire. Now I went a little bit up and I went to 1/0 gauge, but it can't hurt because if anything, it'll just minimize voltage drops. Now, when picking fuses and circuit breakers, the general rule of thumb is you want to take the current that you expect to pass across these wires and multiply that by 1.25. For example, my circuit breaker is rated for 40 amps. Because of this, I took 40 times 1.25 and got 50. And so I bought a 50 amp circuit breaker to protect my charge controller. On top of this, I also bought a 100 amp circuit breaker to protect my DC fuse box and a 300 amp fuse as my main fuse. Now, you're going to need a main fuse, and I would also recommend a main bus bar, which is basically just a piece of metal that allows you to connect things to them. And you're going to want these as the main connection points from your batteries to the rest of your system. So those are the main components that you're going to be looking for the base of your electrical system. Once you have those components, you can actually hook it up and turn it on. That is what I would recommend as a first step for hooking up your electrical system. Get these components purchased and assembled, and then from there, you can look into how you actually want to hook up your DC and AC systems. Another thing that's not necessary, but you might want to consider getting is a battery monitor. I have a really awesome battery monitor that I will drop in the comments below that I definitely recommend. It's super cheap, but it does the job. Cool. Well, now that we have a rough idea of all the components that we want, let's take a look at the system behind me and we'll dive in. What we've got going on here, first of all, we've got our Victron Multiplus. So this is an inverter charger combo. This is a really quality piece of equipment here. It's a 3,000 watt inverter. So a lot of power there. Then down here, we've got a 40 amp charge controller. Nice charge controller here. We'll be able to handle both of our solar panels and send that down to our batteries. Over here, we'll go to this one next. We've got our DC fuse block. So this is for connecting all of our DC components to our solar system. And so those are gonna be the three largest components here in the setup. Then these smaller components, we've got two circuit breakers. So we've got a circuit breaker for our DC fuse block. Not 100% necessary. If there's too much amperage, this will always just blow. However, rather than blowing 15 small fuses, we'd rather just trip a single circuit breaker. So it's nice to have this downstream of here. Then we've got our 50 amp circuit breaker for our 40 amp charge controller. And if you're curious, how we pick the sizes on these, you want to go about 1.25 times the amperage of the component you're trying to protect. And so since this is a 40 amp charge controller, 40 times 1.25, we went with a 50 amp circuit breaker there. Then the rest of the components, we've got, so this right here is a shunt, and this is for connecting our battery monitor so we can monitor the voltage in our system. And then finally, we've got our main positive fuse. This is a 300 amp fuse. And we've got our main negative bus bar just for connecting the batteries to the whole system. Then over here, we've got our two batteries. So we got these from bigbattery.com. They're each 2.45 kilowatt hours. So we have a ton of power. And then back here, we'll check out the tools that we have to use today. First, we'll start with our wire. So here, we've got a couple different wires. We've got our 1/0 gauge, and then we've got 6 gauge. To connect our batteries, we've got 6 gauge wire connected to Anderson SB 175 connectors. We've got a drill just for screwing in everything we need here. A heat gun for shrink wrap. We've got our gloves, crimp connectors here for connecting wire. We've got a handful of different gauges for that. So we've got our 6 gauge, our 1/0, and then a couple different hole sizes. Then as far as tools go, we've got these for stripping wires. These are really nice. We've got a pair of wire cutters, some pliers, can never go wrong with those. And then the big boy, we've got our hammer type crimper. Multimeter here for checking leads and stuff. So yeah, so that's all the tools we're gonna be using today. So let's hop on in and let's get started. Power delivers. We're going to start hooking up the positive leads for the main fuse, the 2 circuit breakers, the DC fuse box, the charge controller, and the inverter. There we go.
But this is like a really wide part.
Oh!
That's f***ing sexy.
It's right there.
But you guys understand. I used to have that problem a lot when I was a kid. And then
So I'm gonna plug in these batteries. We're gonna flip the breakers, and we're gonna know it's working if this green light, if this light turns green.
Oh, baby!
Did it. For now, I don't want to get too excited, but we have successfully powered the charge controller and the inverter, so feeling good. Hey guys, thanks so much for checking out this video. If you enjoyed it, don't forget to like, subscribe, and hit the bell button for new videos every Thursday.
And if you want to learn more about the bus conversion process, or you just enjoy watching us do it, feel free to watch some more of our videos over here or over here. That felt pretty good.